Hi everyone, and welcome to the fourth and final video going through some past exam questions on the topic of acids and Ka. In this first question here, it's looking at this calcium hydrogen sulfate. Can be made by reacting an excess of sulfur dioxide gas with a suspension of calcium carbonate. Write the equation for this. Okay, so this is not something really acids related, but these kind of questions come up quite a bit of just write an equation for some random reaction, and usually students are quite bad at them. So let's see what we're doing here. We're reacting sulfur dioxide gas, okay, with a suspension of calcium carbonate in water, right? And the water is important because otherwise where else is the hydrogen going to come from? So the water is actually part of this reaction. We know it's going to go and make this. So then it's just a case of trying to balance this out. Well, hang on. Where's the carbon gone? We've got no carbon in the product, so there must be some carbon dioxide gas being produced, which would make sense for a carbonate. That seems fine. So then what have we got? We've got the calcium, we've got the carbon. We're going to need two SO2s, aren't we, to get the two sulfurs, which makes sense because it says an excess of sulfur dioxide gas. Now we're just trying to balance this then. Calcium, calcium, carbon and carbon, two sulfurs and two sulfurs. Two hydrogens and two hydrogens is looking good. 4 oxygens, 5, 6, 7, 8. 3 times 2 is 6, 8. Okay, brilliant. So that wasn't too bad, right? So it's just using everything they've told you. Sulfur dioxide, calcium carbonate, water. There's my product. Usually these kind of questions have an extra product that they don't tell you about because the exam board likes to think they're sneaky. But here it's just spotting that the carbon is not being used. Okay, calcium hydrogen sulfate dissolves in water to make a solution that is weakly acidic. Okay, what is meant by a weak acid? So it's an acid that partly dissociates. Write an equation to show why this is weakly acidic. So here we've got to be careful. So remember, if it's an acid, it's a proton donor. So this solution contains calcium ions and these ions. So which is the thing that's actually an acid? It must be this ion. That's the only thing that's got a proton that it can donate. So it must be these ions donating their proton to make SO3 2- ions. Okay, I mean, calcium is not acidic, is it? That's just calcium, so it must be this. And because it's a weak acid, we've got to have this equilibrium symbol. Okay, aqueous solution of this oxidizes magnesium, forming hydrogen gas. Construct full and ionic equations. Okay, so we've got this thing reacting with magnesium. What are we going to get here? So we're going to get hydrogen gas. Obviously, it tells us we're going to get hydrogen gas. And then what we're going to end up with is it's reacting with the acid. So it's this ion doing this. So these H+ ions would then react with the magnesium and turn into hydrogen gas. So we'll be left with these SO3 2- ions, one of which is then going to make a salt with the magnesium. The other one's going to make a salt with the calcium. So we're going to end up with calcium, SO3, and magnesium and SO3. So in terms of the ionic equation then, the calcium ions are going to cancel out. We're going to be left with the magnesium metal plus the HSO3- ions. There's two of those, isn't there? Yep. Okay, see how this is going to work. So two of those ions, that's going to react. That's going to give us our Mg2+ ion that's gone in the magnesium sulfate here. We're going to end up with hydrogen gas, and we're going to end up with 2 of the SO3 2- ions. Yeah, one that ends up in the magnesium sulfate and one that ends up in the calcium. Okay, so we've just cancelled the calcium ion from here and from here. Okay. Is this balanced? We've got 2 negative charges on the left, 4 minus charge, but 2+. So the charges do balance. We've got a total of 2 minus charge on the left and a total of 2 minus charge on the right. That is quite a tricky one, I think. This is a bit unusual. It is one that you do want to be careful of. Then it's saying this ion can either act as a bronzodilary acid or a bronzodilary base. Explain this, include equations. Okay, so let's do the equations first. So if we have HSO3 minus, if that reacts with H plus, then we're going to end up with H2SO3. Okay, so what's happened here is the HSO3 minus ion has acted as a base by accepting a proton. If we then do the equation for it reacting with OH minus, it's going to donate its proton. We're going to end up with the SO3 2 minus ion that we saw before and water. And we can say that HSO3 minus has acted as an acid by donating a proton. The key thing here is that you've linked together whether it's an acid or a base with what it's done with a proton and then link that to the equation. So the fact that you've got all these three things all together is really important. Okay, what sometimes people do is they write this, then they write their two equations. But it's the fact of going, look, that's linked with that and that's linked with that. Okay, rather than just writing it as a series of 4 statements, making it clear which ones go together. Okay. Right, the last question I want to look at is quite a long looking one here. So what's going on here? We've got this carboxylic acid, we know its Ka value. They've done some stuff. They want you to work out what the molar mass of the acid is and its possible formula. Okay, so where do we even start? Any type of acids kind of question, you start in the same place, start with Ka. Right, Ka is your friend. Okay, if you start with that, it can give you a clue as to what you're doing. Okay, here we can write it as A minus and HA because, well, we have to. We don't know what it is, do we? Okay, what do we know here? We know what the Ka value is. We know what the pH is. Okay, so we can get the H plus concentration. We know it's a weak acid, don't we? So as a weak acid, we can do our trick that we usually do and say that it's H plus squared. And then we know what the Ka is, and we can use the pH to work out the H plus concentration. So it must be the HA that we're trying to work out. So let's do that. Right, and can you see at the moment, I've not really got a plan for how this question is going, but just by writing out Ka and looking for what I've already got this, and I can work out the H plus from that. So therefore it must be this that I'm supposed to be doing. Okay, and then once I've got that, we'll see where we can get from there. Okay, so the HA concentration, we multiply by that and divide by Ka. So that's going to be H plus squared divided by Ka. So let's do this then. So the HA concentration is going to be, the H plus concentration is going to be 10 to the minus 3.52. Yeah, we're doing 10 to the minus pH. So it's that squared over Ka, which is here, 1.51 times 10 to the minus 5. Right, let's work that out. 10 to the minus 3.52 squared divided by 1.51 times 10 to the minus 5. So we've got 6.04, let's call that, times 10 to the minus 3. That is our HA concentration in moles per decimeter cubed. Right, okay. So now we can see we're starting to get somewhere. We've got the concentration of HA. We want to get the molar mass. So what we can do then is, if it's moles, we're just looking at how do we convert these units, how do we go from there into those units, right? So we need to get rid of the decimeters to the minus 3. So we need to times by decimeters cubed, and that'll get us moles, won't it? And then do grams divided by moles. So we need to times by the decimeters cubed, which is there anything else? No, it's just 1 decimeter cubed, wasn't it? Okay, so let's do that. Let's times it by 1 decimeter cubed, and we've now got 6.04 times 10 to the minus 3 moles. And now we can do grams divided by moles to get the molar mass. 0.7369 grams divided by 6.04 times 10 to minus 3 moles. And I'm going to use the full, I've still got the full number on the calculator, yeah, because it's not actually 6.04 as it is this number. So we're going to do 0.7369 divided by that answer. And we're going to get 122.00. So we'll call that 122, that's fine, that's worked out quite nicely. So we've got to this point, and again, can you see we've just done it by doing Ka and seeing where we get to. Okay, and this is the way that you have to approach a lot of these sort of unusual acids type questions, where we'll just see where I can get to. Right, what's the possible formula? Right, what does it tell us? It tells us it's got 1 carboxylic acid group, and it's only carbon, hydrogen, and oxygen. So if we know that it's got COOH, let's add that up. Okay, so let's say the MR of COOH is equal to 12 plus 16 plus 16 plus 1. I will mess this up. I'll do it in my head. 16 plus 16 plus 1. 45. Okay, so now we're going to do 122 minus 45, which gives us 77 for the rest of it. And we know it's only got carbon, hydrogen, and oxygen in it. Okay, so we just need to find some combination of that adds up to 77. Now, the easiest thing, it would be nice, wouldn't it, if the only oxygens were in the carboxylic acid group. So can we make, if it's just carbon and hydrogen, can we make that add up to 77? Multiples of 12. Yeah, this is going to work. So if we divide, if we divide 77 by 12, we get 6 and a bit. So it's got 6 carbons in it, probably, and some number of hydrogens. 6 times 12 is 72, which if we take that away leaves us with 5. So that's telling us then that we've got 6 carbons and 5 hydrogens. So it's going to be C6H5 and then the carboxylic acid group. So it's benzoic acid. And this is the way you do it. You just do a trial and error. Take off the bit you know about, and then you do just have to do trial and error. Find some combination that adds up to 77, and you think, well, it could be anything, but there's only a certain number of combinations, right? That's perhaps the easiest way of doing it. Is going, right, how many times does 12 go into that? 6 and a bit. Okay, let's try 6 carbons. How many hydrogens does that give me? Is that reasonable? If you end up with 6 carbons and 1 hydrogen, that's not right, is it? You can't make a formula out of that. And then you just go back to, okay, try 5 carbons then, and just keep going until you can find something sensible. Right, finally, the student had considered analysing the solution by carrying out a titration. The student rejects this method as being invalid because it's a weak acid. Only a small proportion of H+ ions would be neutralised. Explain whether the student was correct. So this is a strange question, and what the student is saying is, this isn't going to work, right? Because it's just a weak acid, it's only going to partly dissociate. So you're only going to neutralise the H+ ions that have dissociated. And then all the ones that are still part of the molecule, they're not going to have reacted. So you're going to end up with the wrong answer. Okay, that's not true though. Okay, because yes, it's a weak acid, it will only partly dissociate. But if it's reacting with a base, you will end up reacting the whole of the acid. Okay, because once the H+ ions are neutralised, more of the acid HA dissociates. Okay, because you've got this equilibrium. Okay, once you neutralise the H+ ions that are there, the equilibrium shifts to the right, and more of the acid dissociates. Then you neutralise those H+ ions, more of the acid dissociates, you neutralise it, and so on until you've used up all of the acid. all of the HA will react with the base. The student is not correct. Okay, you can do a titration with a weak acid. It's fine.